Welcome to the debate. Today, we're diving into a really deep paradox at the heart of the multi-trillion-dollar global logistics sector. On one hand, you have digital transformation promising to fix massive inefficiencies in global ports, a market valued at what, over $12 trillion? But on the other, the leading solution, blockchain, has this structural challenge it just can't seem to shake.
And that challenge is fundamental. We call it the garbage in, garbage out principle, or GIGO. Everyone celebrates blockchain for being immutable, for creating this perfect, tamper-proof record. But in the real world of port operations, which is messy, it's physical, that immutability suddenly becomes a huge liability. If the data you feed into that ledger is false to begin with, well, all you've done is create an immutable lie. And we are seeing fraud persist despite all this investment.
See, I'd frame that very differently. I don't see a fatal flaw. I see a necessary evolution. GIGO is a data challenge, sure, but it's inherent to any major digitalization project. The immutable ledger is, frankly, the best tool we have to fight the kind of systemic, hidden fraud that plagued the old paper-based systems. I mean, the transparency it introduces, especially when you pair it with something like IoT integration, it just drastically shrinks the opportunity for fraud. We're already seeing the results. Claims processing cut from weeks down to hours.
So I think that really brings us to our central question for today. Is blockchain technology, which was designed for digital transactions, truly capable of solving the massive systemic problem of data manipulation in port logistics? I'm going to argue that GIGO completely undermines its core value proposition if that physical source of data isn't secure.
And I'll argue that the targeted, multi-layered security integrations we're seeing in advanced smart ports provide more than enough mitigation. The efficiency benefits they deliver, well, they just radically outweigh the risks.
My core concern, and really where this all starts for me, is the fact that blockchain guarantees the integrity of the record once it's on the chain. We can agree there. But it has, absolutely no native ability to guarantee the veracity, the truthfulness of data that comes from the outside world. And this isn't theoretical. When data is punched in by hand or fed in through a compromised oracle, the entire chain is polluted from the start. I mean, the history of trade is just littered with examples of documentary fraud that a simple digital ledger can't fix.
Okay, but even if we accept for a moment that some flawed data might get in, the very act of making that record transparent and cryptographically secure completely changes the economics of fraud. Traditional systems thrive on being opaque, on these information silos between shipping, customs, and the port authorities. That's what let fraud go undetected for years. We have pilot projects showing that just introducing a blockchain can cut documentation processing times by up to 80%. That shared record creates a layer of accountability that simply wasn't there before.
But those efficiency gains are mostly about optimizing paper flow. They're not a hardened defense against sophisticated, intentional criminal activity. We have to look at precedents. Take the Hin Leong scandal in Singapore. Here you have a massive oil trading company that for years was forging bills of lading, the core document in trade, to defraud banks of $3.5 billion. They were targeting the very documents that blockchain is supposed to secure.
And that scandal was entirely rooted in the weaknesses of a centralized paper-based system. It's cheap and it's easy to forge a piece of paper and hide it. But when you move that onto a distributed, cryptographically secured ledger, the complexity and cost of an attack just goes up exponentially. You can't just shred the digital file.
But the goal of the fraudster doesn't change. Their goal is to input false information. The mechanism just changes from a pen to, say, a compromised API key or a manipulated data feed. And beyond that, we've seen even the biggest, most well-funded consortiums fail to overcome the friction in this sector. I mean, look at TradeLens. It was powered by Hyperledger Fabric, huge backing, and it struggled significantly with adoption.
That is a vital point, but we need to be very specific about why it struggled. It wasn't really a technological failure related to GIGO. It was a commercial one. You had these huge global carriers who all agreed the tech was good, but they were fundamentally unwilling to share the proprietary, sensitive operational data that you need to make the ledger work. The friction was political, it was competitive, not because the immutable record itself was flawed.
Exactly. And the difficulty of getting global competitors to agree on sharing inputs, that just proves my point. The system's greatest vulnerability is its reliance on verifiable source data. If one party withholds data or skews it, the chain is incomplete and its value just evaporates. That fragmentation is exactly where fraud finds a way in.
I agree, adoption is a challenge, but the benefits in stopping known types of fraud are already being measured in other sectors. Look at insurance. It has a similar multi-party claims process. Blockchain systems there have helped prevent up to 65% of application fraud, and insurers have reported an 80% drop in duplicate claims. That level of fraud mitigation, it translates directly to logistics. It justifies the investment.
That's a compelling point on the documentary side. I'll give you that. But let's shift to the physical world, which is a much, much harder GIGO problem. The vulnerability isn't just about data entry, it's the physical security of the sensor. Let's take a shipment of, say, frozen fish. The driver has a contract to keep the cargo at a specific temperature, but maybe he wants to save on fuel costs by turning down the refrigeration.
Okay, so the sensor, the oracle, reports a breach, and it's recorded on the chain.
Not necessarily. What if the driver just takes the sensor and puts it in a small ice cooler he has in the cab with him? The sensor's happy, it keeps reporting a perfectly compliant temperature back to the blockchain, while the actual fish in the container are thawing. The ledger now has an immutable, perfect record of a complete lie about the physical state of the cargo. The system's been duped.
That physical tampering risk is, you're right, it's the pinnacle of the GIGO challenge. And it requires a dedicated architectural response, which is exactly what the most successful smart port models are now deploying. You can't solve a physical security problem with software alone. You need an integrated solution. Look at what they're pioneering in the UAE, especially in Dubai, at hubs like Jebel Ali Port.
So walk me through that. How do you stop that driver from moving the sensor?
It's about securing the data as close to the source as possible, using a multi-step architecture. First, you establish what we call sensor trust. These aren't just simple thermometers. These IoT devices track location, acceleration, light exposure, humidity, and crucially, they're often built into tamper-resistant seals or casings that send a cryptographic alert if someone tries to interfere with them. You build in redundancy, so you need consensus from multiple data points before a smart contract executes.
Okay, but putting tamper-resistant seals or specialized hardware on every single cargo sensor, that exponentially increases the cost and the complexity. I mean, how is that scalable across the millions of shipments moving through the supply chain every day? And what about data latency?
And that brings you to the second architectural step, real-time anchoring with edge computing. This is key to managing that massive data flow. Instead of sending raw data from every sensor all the way back to the main blockchain, the IoT device itself pre-processes it right there at the source. It calculates a secure cryptographic hash of that data. We're talking milliseconds after it's collected. And then it only syncs that tiny hash to the ledger. This minimizes latency and makes the data tamper-proof almost instantly.
I see the technical elegance there for handling scale, I do. But we're still assuming a secure input. The security boundary just moved from the data center to the device itself. A dedicated attacker can still target the physical hardware, which needs constant maintenance, key management, security patching. Which leads to the final, and I think most critical step, automation and stakeholder dashboards powered by smart contracts. The system is designed to take the human element out of critical decision points. So if all the verified sensor data, temperature, location, seal status, if it all meets the pre-agreed conditions, a smart contract automatically executes. It releases payment or it authorizes customs clearance. And because it's a permission blockchain, only authorized parties can contribute or verify data. It just dramatically limits the chances for human error or manipulation.
I acknowledge the sophistication is increasing, but we have to come back to economic viability. Securing all these inputs with dedicated hardware and application-specific solutions is a massive capital investment.
We're talking about retrofitting legacy ports that handle low-margin goods. I mean, if the tech requires a special seal on every package, the implementation cost is just going to overwhelm any potential efficiency gains for a lot of operators.
But you have to reframe that cost. It's not an expense, it's an investment against massive ongoing losses from fraud and spoilage. McKinsey reports that this kind of integration, even in hybrid systems, can cut operating costs by around 30% through automation. And the efficiency gains, cutting the time goods sit at a port from weeks to hours, that creates a huge competitive advantage for anyone who adopts it early.
A 30% reduction is significant, yes, but that figure is often based on the most optimized top-tier systems. For an average port dealing with legacy ERP systems, the interoperability issues alone create a huge drag on that ROI. The break-even point gets pushed out years and years.
The blockchain layer for high-trust activities, like verifying a shipment manifest, while legacy systems handle basic inventory. The value delivered by that verifiable data layer, even when it's only partially adopted, is foundational. It's what's positioning places like Dubai and major U.S. ports to become the new benchmark for trade. It's a strategic move.
At the end of the day, what we're seeing is a shift in the attack surface, from forging paper to manipulating the digital input. And that's not a solution unless the costly, complex mechanisms for securing the physical source material are universally implemented. If you can't audit the inputs cost-effectively, then the immutable ledger is just a permanent record of flawed data. The work has to start with securing data ingestion, not just celebrating the ledger's security downstream.
And I agree with you completely that rigorous ingestion standards are paramount. That's where the focus needs to be. But we have to reiterate that this technology is foundational for the future of smart ports. The risk of GIGO, especially as it's being mitigated by these new layered IoT architectures, is far, far less destructive than the inefficiencies and untraceable fraud of the old systems. What blockchain is delivering right now, verifiable data, expedited documentation, is already providing massive, quantifiable value.
The tension remains. The ledger is secure, but the physical world it's trying to map is not.
Indeed. And while we may disagree on the best technical solution, the value of bringing transparency and accountability to global logistics is undeniable. The debate is clearly shifting from whether we should implement blockchain to how we can create reliable data standards across every single part of the supply chain. And there's clearly so much more to explore there.